fronts. Again, we have stationary front, symbolized by the red round for our warm front and the blue triangle for the cold together. This is when we've got air mass moves in, we get to the boundary, but then they stop and stay in place for a while. And so we've got cold air moving along the cold side, warm air along the warm side, and this tends to lead to often wet, stormy weather along the front while it's sitting there. Now, these definitions are relative. In the wintertime, a warm front might be only, say, 5 degrees Celsius. If the air already was 0, 5 is warmer than 0. Similarly, in summertime, a cold front might be bringing the temperature down from around 30 degrees Celsius to 25. 25 Celsius is not particularly cold, but it's colder than it was. So cold front, warm front, those are relative to what was already there. If temperature gets warmer, it was a warm front. Temperature gets colder, it was a cold front. Okay, so here are patterns. If we have the blue for cold and the kind of, it's not very pink, but this stuff for warm. This top one here, we have a very steep front. This is typical of our cold front pushing in. This bottom one, much more gradual slope. This is typical of our warm front coming in. So here we have the cold pushing in, and wind blows up and over with the warm front rising more steeply, faster rising, tend to make cumulus and thunderstorms. The somewhat more gradual rising of our warm front goes along with making stratus clouds, overcast, maybe precipitation, but a more gentle, sustained precipitation rather than the fast storms. Cyclones are third thing. What is a cyclone? Inconveniently, there are at least 3 different ways the word cyclone is used in meteorology. And so we have to clarify what we're talking about. Sometimes people use cyclone as a synonym of a tornado. That's not what we're focused on here. Also, in the Indian Ocean region, what we call hurricanes here around the Americas are called cyclones. Now, both tornadoes and hurricanes are cyclonic systems, but they are only certain categories. We're using cyclone here as any sort of low pressure system. This includes big severe storms like hurricanes and small severe storms like tornadoes, but it also includes just the pressure is a little lower. It does not have to be a very dramatic cyclone here. So we're using cyclone to mean any sort of low pressure system. Again, winds will tend to blow towards the low, but as always, we're on Earth. Earth is spinning, and so we need to keep in mind the Coriolis effect. So the winds here in the northern hemisphere will bend counterclockwise into the low. Winds coming in from all directions, so that air has to go somewhere. It's going to be going up. Rising air. As air rises, as we saw, it's going to cool, adiabatic. As it expands, the temperature goes down, less pressure on it, and cooling air eventually will cool down to the dew point, and we'll start to make clouds, maybe even some rain or storms if the low pressure system is strong enough. In contrast, anticyclones are any high pressure system. High pressure, air sinks down, reaches the surface, and moves out away from the high pressure. But the Earth's still spinning. And so our winds will be curved with the Coriolis effect. And here in the northern hemisphere, they will bend clockwise as well as moving out from the high. High, our air is sinking, encountering more pressure. As the pressure goes up, our air is warmed. Again, adiabatic. You like the big word there. As air warms, we could have more evaporation, so the relative humidity decreases as the air sinks. If there were any clouds, they'll evaporate. So high pressure is associated with clear, sunny, fair weather. Now this could be clear and cold, or it could be clear and warm. It depends on other factors there, but clear with our high. You sometimes hear this described as rising or falling barometer. Barometer, as we'll see, is a device for measuring the air pressure. So if the air pressure is falling, that means the air pressure is getting lower. A low pressure system is approaching. So if you have a barometer and you notice the pressure is getting lower on it, that suggests that we're in for at least clouds, maybe stormy weather. If the barometer is rising, meaning that the pressure is going up, high pressure is on the way, and we're going to be seeing some sunny weather coming. Okay, but will we get a storm? Well, that depends on how stable or unstable the air is. By stable, we mean air that tends to resist moving up and down. It will tend to stay put. Unstable air is air that tends to move up or down easily. If it gets going, it tends to keep right on going. Why does air move up and down? Again, as you saw in the water, mostly it relates to density, warmer and colder air. Well, of course, the ocean was warmer, colder water. And this affects our pattern of weather and how much air mixes. Now, too stable air, stagnant is not good. You do want some air motion, but moving very rapidly, very unstable air is what gives us storms. Thinking about air moving up and down, well, let's go back to water. Water behaves a little bit more consistently than air, so we'll start with that simpler example. If we have cold, denser water on top of warmer water, more dense, all that cold stuff is going to sink, it's going to mix. But if we have less dense warm water on top of denser colder water, we can get layers. So you were able to get some layering in that first lab way back when, if you still remember that, with the warm versus cold. And so that difference is stable, and things tend to not mix as much. Gas, like air, it's compressible. So we've got complications. Air moving up and down. Not only do you have is it warm or cold, but again, as air moves up, it expands and gets less dense and gets cooler. As air moves down, it shrinks. It's under more pressure. It condenses. It gets warmer. So we've got these complications going on. Also, in air, we've got water with its latent heat potentially hitting the dew point and causing changes there. If we have warm air, it's less dense, tends to rise. Higher balloons do go up. But as that air rises, it's tending to cool off. So we've got these extra complications to think about. And then, as I mentioned briefly, water plays a role. If we've got air with the water vapor in it, that rises, cools, and expands, hits the dew point. Now, instead of going into changing temperature, some of that cooling is going into taking up the energy being released as the water goes from zipping around as gas two more stuck together is water, the latent heat of condensation. So water is releasing the latent heat, counteracting that cooling. So our air stays warm, it does not cool off because we have condensation happening in it. And so it's not adjusting. Okay, stability of air. This is a big factor in telling us, it largely determines, is our air going to be stormy or is the weather going to be more stable? Again, air moves up and down. We get changes in the temperature and the density. And our key thing is, how does that particular air above us compare to the air generally around? The adiabatic lapse rate of that air above us, the air that we're interested in, how does that compare to the surrounding atmospheric or environmental lapse rate? The atmospheric lapse rate or environmental lapse rate, that's just how does the air around the air of interest change temperature as you go up. What would you get if you stuck a thermometer on a balloon and measured the temperature as it went up? So you have to measure that. It will depend on the local weather and just how high up you are in the different zones in the atmosphere.